Today we're going to look at binary operations. All binary operations are the universe of operations other than plus, minus, multiplication, and division. When you take two values, A and B, all we've been able to do in the past is add them together, subtract them, and so on. Did you ever feel like you were getting ripped off, that there should be others? Absolutely. So all the time. So there is this thing called binary operations that says there's a whole universe of other things we could do. I gave you this example yesterday. If I took 3 star 11 and I got, let's say I got 36. Okay, what would 2 diamond, I guess it's not a star, is it? 2 diamond 5, what would that be? Okay, how about 4 star diamond? And diamond, let's go 20. What will that? That doesn't even look like a star. It's what? 64. So what is happening to A and B here if I go A diamond B? What is that? A plus 3B. So that's the operation of what we're calling a diamond star. So let a binary operation be A star B, A plus 2B minus 3, and you can do all these things. Now today's is going to be pretty straightforward. We'll talk about closure in a moment, but when we start looking at associativity, commutativity, and distributive part on Tuesday, things get a little bit more interesting. But for right now, what would 3 star 5 be for this binary? Yeah, it would just be 3 plus 10 minus 3 is going to be 10. How about 0, 3? 0 plus 3, yep, so that'll be 6. So you can see how those work out. Perfect. All right, next. Closure. When we talk about closure, you think of closure as ending something, but actually this is a beginning process. You got to make sure that all the elements of S exist for your operation, and so they do something kind of interesting here that they say that closed on S means that A star B is an element of S, and A is an element of S, and B is an element of S. So in other words, A star B, A and B are elements of S. That's what closure means. All 3 of these has to be taking place to be closed. And we'll talk about other binomial things with that. Determine whether the following binary operations are closed for, what's Z again? Integers. So then we'll take A star B. Do you think A plus B over A squared is going to be closed? How could we show that it's not? Counterexample. Just come up with one. Let's do it before I reveal here. Counterexample, what do you think? Let's let A equal to what? I love it. 0's good. Let's try 3. 0 is a little interesting. Sometimes it's a different reason, but let's try 3 and B is 2. So you're going to get 3 plus 2 over 4, or 4, 9, right? And is that an integer? Boom, done. And you can look at these other ones, find a counterexample. I like these. You'll be doing quite a bit of this in the assignment. Yeah, they use that one. You've used -2 and 0 is interesting because you'll get 1/4. 2 to the -2 is 1/4. Not closed. This last one is closed. A and B are integers, and if you multiply and multiply by 3 and subtract, it's going to be fine. So that's really all there is to this one, is checking for the operations and checking for closure. Closure, you just have to make sure that A and B are elements of whatever they're saying that set is. And then A star B also has to be an element, and you can check that out. And that's binary operations. We'll look at proving them for different properties on the next lesson.